Hello, first grade teachers. Welcome to the Unit at a Glance video on demand. The purpose of this video is to provide you with an overview of the standards, intended pacing, and sample instructional strategies for Unit 3B, Shapes and Patterns. In this portion of the video, we are going to review the AKS and Indicators of Achievement, or IOAs, for Unit 3B. The AKS are the overarching knowledge and skills that students are expected to master. The IOAs are the learning objectives that allow students to demonstrate mastery of the AKS. Remember, some AKS and IOAs will appear multiple times throughout the year to build and deepen student understanding. In Chapter 2 of the video, we will look to see how the AKS and IOAs in this unit are paced in detail. Let's look at the AKS and IOAs we will be teaching in this unit. Unit 3B has one AKS, AKS 3. AKS 3 involves identifying, describing, extending, and creating repeating patterns, growing patterns, and shrinking patterns. Under the AKS, you will find the Indicators of Achievement, or IOAs, that we are teaching at this time. The IOAs go into further detail about the expectations for the standard. For AKS 3, we are working on both of the IOAs, 3A and 3B. IOA 3A focuses on repeating patterns. Students will investigate, extend, create, and make predictions about repeating patterns. The repeating patterns students work with should have a core, the part that repeats over and over, of up to 3 elements. A series of shapes or numbers may be the core in the repeating patterns. Students have background knowledge of repeating patterns from kindergarten. IOA 3B focuses on growing and shrinking patterns. Students will identify, describe, extend, and create growing and shrinking patterns. These patterns increase or decrease by 1s, 2s, 5s, and 10s. This is a new concept for first graders. Now let's look at the pacing guide to see how the AKS and IOAs have been paced out over the course of Unit 3B. In this portion of the pacing guide, we see the name of the unit, the big ideas for the unit, and the suggested pacing. Unit 3B will focus on patterning and algebraic reasoning. The suggested pacing for the unit is about 2 weeks. In the next box, we see the AKS and IOAs that will appear in the unit. Unit 3B teaches AKS 3 through the IOAs 3A and 3B. The left column of the pacing guide will list the progression through concrete, representational, and abstract strategies. The bullets also indicate the learning objective for the day, as well as any suggested manipulatives. The right column of the pacing guide shows the instructional resources that align to the intended learning objectives for each day of instruction. You will either see instructional resources linked for the numeracy components of a traditional teacher-led lesson, like the first day of the unit here, or a task-based lesson, which will be your full numeracy block for that day. Notice the second day of the unit. We begin the unit with about 3 days of instruction on repeating patterns, IOA 3A. We pace this IOA for a shorter amount of time because students have worked with repeating patterns in kindergarten. Students will use a variety of manipulatives to model repeating patterns, like pattern blocks, counters, snap cubes, color tiles, geometric shapes, and bears. The repeating patterns will have a core of up to 3 elements, like an AB, AAB, or an ABC pattern. We have placed more time, about 5 days of instruction, on IOA 3B because growing and shrinking patterns are a new concept for first graders. At the beginning of the year, students rote counted forward and backward by 1s and 10s within 120, so they can build their new learning of patterns on this background knowledge they have. We will also lean on the counting strategies they have developed for counting on and counting back, and apply these counting strategies to growing and shrinking patterns that increase or decrease by 1s, 2s, 5s, and 10s. At this point in the year, keep in mind that students have only added and subtracted within 20. So when the numbers in a growing or shrinking pattern go above 20, students will use counting strategies to determine how the pattern is changing and to be able to extend the pattern. They will not be expected to add or subtract 1, 2, 5, or 10 from any 2-digit number within a pattern. Growing and shrinking patterns are introduced concretely with a variety of manipulatives to help students see and count how the pattern is changing from one step to the next step. Individual manipulatives like counters, color tiles, and shapes work well for patterns that increase or decrease by 1s or 2s. Snap cubes represent those changes well also, but are helpful for 5s because the cubes can be connected in sets of 5s. The base 10 block, 10 rods, and 10 frames model growing and shrinking patterns by 10s well. Representationally, a hundreds chart is a great tool to visually see growing and shrinking patterns, as well as to be able to notice other characteristics of the numbers in the pattern, like where they fall on the hundreds chart and the noticings of the digits in the 10s and the 1s place. Number lines can also be used as a representational strategy for identifying, describing, and extending growing and shrinking patterns. Chapter 3 of the video will highlight specific instructional strategies that will be utilized in this unit for the IOAs 3A and 3B. Please refer to the Analyzing the Standards, or ATS, for guidance on additional instructional strategies for each IOA. Okay. Now, since this is our first year of new math standards, that also means that this is your first year of teaching patterns to first graders. That has not been an AKS previously. So in this video, I am going to walk you through the different types of patterns that first grade students should be working with and highlight some of the key academic vocabulary for you as well. So let's begin with IOA 3A, and that's all about repeating patterns. So I have a problem here from one of the concrete lessons on the pacing guide. So let's take a look at this problem. It says Rylan made a pattern, describe his pattern, and build the next 3 terms. Okay, so with repeating patterns here, students are investigating, describing, and extending the pattern. Okay, so I have some concrete pattern blocks to match this image we're seeing here of the pattern that Rylan made. So I'm going to go ahead and build Rylan's pattern with the pattern blocks. Okay, make sure I match it exactly to what I see in the image. Right, and then I'll just scoot this up here so that we're just looking at our concrete. manipulatives. All right, so one vocabulary term, funny enough, I'm actually seeing up here, is we're supposed to describe his pattern and build the next 3 terms. Okay, so just for you to know, and if students see that within a situation or a scenario, each of these elements is a term in the pattern. So when they ask us to build the next 3 terms, they're asking us for the next 3 shapes in that pattern. Okay, so just so you're aware of that. Now, looking at our pattern as students are investigating, right? In a repeating pattern, what makes it a repeating pattern is that it has a core that repeats. So we're looking to see if we can find that core. That's the goal for students, to be able to identify the core of the repeating pattern. Okay, so we're looking and I can see yellow hexagon, red trapezoid, green triangle. And then I see this yellow hexagon repeating again, right? And then if I look at the next element, I see that the trapezoid repeats again. And then the third element here is the triangle that also repeats again. Even the orientation of the triangle, the direction it's facing, is repeating. So the first thing we want to do is to be able to find and identify that core. So you might want to put a bracket around it or even circle it. Right, so then we can really see here, oh, here's a core that I can see fully repeated again. Just so that you know, teachers, that is one of the considerations you'll see in the ATS, that when students are presented with a repeating pattern, the core should always fully repeat at least one more time so that they can identify and see that full repeating pattern. It shouldn't look like, let's say this, right? Because then I can't tell if that triangle really does repeat again. So the core should fully repeat. Also, when we're talking about repeating patterns, it specifies that first grade repeating pattern should have a core of up to 3 elements, right? So 3 different things that repeat. So the core wouldn't have a 4th shape in it, because then that would mean it has a core of 4 elements, which would be going beyond our first grade expectations there. So AB patterns, ABC, AAB, things like that, but only 3 different elements in that pattern. Okay, so as we're looking at it here, students may describe one attribute of the pattern, which might just be the shape. What do they see? They see hexagon, trapezoid, triangle, hexagon, trapezoid, triangle. So shape might be one attribute they notice that's repeating. They may also notice color and identify yellow, red, green, yellow, red, green. Okay, or they could describe it with both at the same time, yellow hexagon, red trapezoid, green triangle, to describe that pattern. So that's some of the different ways they might describe it. Then we can also label our pattern with letters. And that's another thing that helps students track the core. So we can label it, each different element gets a different letter. So A for that first element, B is different, red trapezoid's different, so I'm going to give it a different letter. And then I see a third different element, so I label it with a different letter there. So none of these elements are the same, so they each get labeled with a different letter. So this is an ABC pattern. We can see A, B, C repeating again. So in order to extend this repeating pattern, I'm going to slide this over just a little bit, right? I know that I'm looking for that A element, that yellow hexagon would come next. Then I'm looking for the B element, which was the red trapezoid. And then finally, that green triangle. And again, just pointing out that even the orientation of all these shapes repeats in the same way. If it was turned a different way, that could represent a different element, actually. Okay, so With those repeating patterns, remember they've got a core that we want students to find and identify. That core should fully repeat, and it should only have up to 3 elements. Each individual element in a pattern is also called a term. Now let's think about growing and shrinking patterns. That's the other type of pattern that first grade students should be working with. So when discussing a growing and shrinking pattern, the goal is for students to consider how each step in the pattern differs from the preceding step. So one good way to do that is to identify the part of the pattern that is the same in the adjacent terms and help students identify what's changing, how it's changing when it goes to the next step. Okay, so that's an important vocabulary word for growing and shrinking patterns. With repeating, we talked about that core and those elements in the core. And now we're going to refer to a step in the pattern. Okay, so let's take a look through this problem and see how we would identify that. So it says Laura eats eggs every day for breakfast. Each day she counts how many eggs are in the carton. And so we see the amount she has counted, 12, 10, 8, and 6. How many eggs will be in the carton tomorrow? Okay, so each of these numbers, each of these amounts is a step in the pattern. Okay, so we're going to build this with some snap cubes, and I already have mine pre-built. So I'm going to start with the 12 eggs she sees on the first day and go ahead and label that step. Okay, and then next I see the next step in the pattern. The next day she saw 10 eggs. The third step in my pattern, the third day she counted 8 eggs. And then on the fourth day, I can see she counted 6 eggs in the cart. All right, so here is each step in my pattern. And the first thing that we want to notice is this pattern growing or shrinking, right? And we can relate that to some other vocabulary, like is it increasing or getting bigger, becoming larger between each step, or is it decreasing? Are the numbers getting smaller? And here, especially since I've represented it concretely, I can clearly tell that there are less cubes in each step. So this pattern is decreasing or getting smaller from step to step. So that'll tell me first that this is a shrinking pattern that I'm investigating. So I need to know how it's shrinking. How is this pattern changing from one step to the next step, right? So these are adjacent steps when we talk about that. So the 2 steps beside each other or next to each other. So a great way to do that, especially concretely here, is to take a look at these 2 amounts, and I'm really going to line them up close together. So I can exactly match the parts between the steps that are the same. And then I'm even going to break off here the difference, right? Just like we would do with a comparison word problem. What's the part that's the same? And then the extra amount is that difference. It represents how much more or how much less between these 2 steps. So in this case, I can see that this first step has 2 more than the second step. So that means that it has decreased by 2. We could also say 2 has been subtracted, or it is 2 less, right? Okay, so if it's a pattern, just like with a repeating pattern, we need to see that this difference, this amount that it's changing by, is the same each time. So right now, I don't have enough information to say that this pattern is shrinking by 2s, right? I'm going to check the next 2 steps. So I'm going to slide these 2 side by side, line them up so that I can see the parts that are the same, that match, and then break off the amount that is different. Okay, so I see again, there's a difference of 2. So this third step here, when she counted 8 eggs, 8 is 2 less than the day before it when there were 10. So 8 is 2 less than 10. 10 was 2 less than 12. So it looks like that is the pattern that it is decreasing by or shrinking by. I've got one more set of steps to check though, just to confirm my thinking. So let's check between that third and fourth step in our pattern. We're going to line them up. Notice the part that's the same, break off that difference. Again, I see a difference of 2. So 6 is also 2 less than 8, or 2 has been subtracted, right? So I've identified now how this pattern is changing. This is a shrinking pattern that is decreasing by 2s, right? We're counting back by 2s. So in order to extend the pattern and find out how many eggs will be in the carton tomorrow, I can think about this step of 6. Students could physically break apart that 2 and count 1, 2, 3, 4. Tomorrow there should be 4 eggs. They may subtract. 6 minus 2 is 4, or count backwards. 6, 5, and then to 4. Lots of ways that they could reach that solution and extend our shrinking pattern to find out what would come next, which would be 4 eggs. If I scoot these up just a little bit, I can go ahead and label that. Let's take a look at another growing and shrinking pattern example, this time at the representational level. So we have our situation here. Describe and extend the following pattern. And I see some terms that are listed, some numbers, right, with 2 blanks. So I need to extend this to the next 2 terms once I determine how this pattern is growing or shrinking. So a great tool that students can use when you have larger numbers like this, since building 55, 60 with snap cubes would be way too much. I could use base 10 blocks, but the hundreds chart works great as well. So at the representational level, I'm going to use this hundreds chart. So I'm going to find each number in my pattern and I'm going to see what's happening, first determining if it's growing or if it's shrinking. So I see the first number in my pattern is 55. So you'd want to have students find the number 55. I'm just going to circle it here. You could use some of those clear color counters that you can see through to lay on top of these numbers as well. The next number in my pattern is 60. So I'm going to come over here and find 60. Next is 65, 70, and then 75 is the last number that I'm given in my series. Okay, so the first thing I'm noticing is that in this pattern, the numbers are increasing. They are getting larger. So I can use that place value understanding that I have to recognize that, because the 10s are increasing as I go throughout my pattern, or maybe I'm just visually noticing that I'm moving down my hundreds chart, and that might give me that cue that these numbers are increasing or getting bigger or larger. So this pattern, I can say, is a growing pattern. But again, just like we talked about before with growing and shrinking patterns, I need to know how it's growing. How is it increasing? Okay, to do this on a hundreds chart, right? Since I can't use that same strategy where I was breaking off the difference between the two, I can use the counting strategies I know, right? So students learned at the beginning of the year how to count forward and backward within 120. So I can use these counting strategies to start at 55. And as I move my finger and count on to 60, I'm going to see how many spaces I moved on the hundreds chart, and I'm going to count those. So I'm going to count 1, 2, 3, 4, 5. So I counted up 5 spaces and landed on 60. So then I want to check and see if that 5 is going to repeat again. Okay, so I'm going to put my finger on 60 and I'm going to count on 1, 2, 3, 4, 5. And I landed on the next number. So it looks like this pattern is growing by 5s, but let's just follow it all the way through to confirm that. So we're counting on 1, 2, 3, 4, 5. Yep, we landed on 70. One more time. 1, 2, 3, 4, 5. And I landed on 75. So each time I counted on or counted up 5 more to get to the next number on the hundreds chart. Watch for students' counting strategies here as they're doing this and make sure that they're not counting this first number as 1, right? That's something we know first grade students might do and think this is 1, 2, 3, 4, 5, 6 apart instead of 5. So just make sure they're not double counting that first number. Okay. So now that I know that this is a growing pattern that is increasing by 5s or growing by 5s, I can extend it and find the next 2 numbers in my pattern by counting on. So I'm going to start at 75 and count on 5 more. 1, 2, 3, 4, 5. So the next number would be 80. Right? That would go here. And then I need to find one more term. So I'm going to count on 5 one more time. 1, 2, 3, 4, 5. So that next number would be 85. Seeing growing and shrinking patterns like this on a hundreds chart can also help students just start to notice some cool patterns on the hundreds board itself, like noticing where these numbers are all falling, so that even visually, I could probably go ahead and predict that the next term is going to fall in this column of the hundreds chart. They might also start noticing some things about the way the digits in the tens or the ones place are changing or staying the same. And notice that in this pattern, since we're counting by 5s, we can see that all of the numbers either have a 5 or a 0 in the ones place. So they can start making some cool noticings about that as well. One thing to keep in mind, if you notice, these are larger numbers, right? So with our growing and shrinking patterns, it says in the IOA by repeating an operation of addition or subtraction. And in our last shrinking pattern, our numbers were within 20. So students may subtract within that one and subtract 2 because they know how to add and subtract within 20. Looking at these numbers here in this pattern, we've got 2-digit numbers that are above 20 that we're working with. And right now at this point in the year, students haven't learned how to add and subtract within 100 yet. So that's why we really want to lean on those counting strategies of counting on and back, because students have counted within that range and they can tell how it's increasing or decreasing by using those counting strategies with larger numbers.
The Georgia DOE's Comprehensive Grade Level Overview states, in mathematics, the emphasis is on the reasoning and thinking about the quantities within mathematical contexts. Specific mathematics strategies for teaching and learning are not mandated by the Georgia Department of Education or assessed on state or federally mandated tests. Students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that are most comfortable for and make sense to them. It is critical that teachers and parents remain partners to help each child grow to become a mathematically literate citizen. These standards preserve and affirm local control and flexibility. Thank you for joining us for this unit at a glance.